Hi, everybody. I'm going to talk about nitrogen management in the Nooksack-Abbotsford-Sumas Transboundary area. Although over the past several days, the name of this project has changed because it turns out that that people became concerned that we're talking about nasty nitrogen, which was kind of what the other acronym came out to be. But so we're changing the name of the project now to the Nooksack-Fraser Transboundary Nitrogen Project, which is now nifty nitrogen. So this is a project that has been worked on by several people. The steering committee is listed up here, but we've had lots of cooperation with a variety of different agencies at the local, state, and federal level. And I'm going to be today just giving an overview of the project. And unlike some of the other science talks, this one isn't burdened by lots of interesting data. So I'm more going to just give a project overview and talk about some of our preliminary results. So I'll give a brief summary of the nitrogen paradox, nitrogen management, talk about some of the goals of this nitrogen project that I'm involved with, and some of the preliminary results from the nitrogen budgeting work that we've been doing, and then just give an overview of some of the key questions that we're grappling with as this project gets off the ground, and where we see it going. Nitrogen management is what we call a question of balance. The nitrogen paradox that I referred to is just that 78% of our atmosphere is made up of nitrogen in the N2 form. Organisms need what we call reactive nitrogen, nitrogen that's been chemically transformed to be biologically and chemically reactive. So we need that excess nitrogen, or excuse me, that reactive nitrogen, but too much reactive nitrogen causes a variety of problems. So the benefits of nitrogen are that it's essential for plant growth and natural ecosystems and crop growth and landscaping. It's essential for human and animal nutrition, and it's essential for agriculture to meet the growing demands of the human population. And so if we look at this graph over time, from the 1850s up to the present, what we see is that human population, as everybody knows, is increasing exponentially. The amount of what we call fixed nitrogen or reactive nitrogen has increased over time as well, from a variety of different reasons. So there's nitrogen fixation by legumes with bacteria in their roots. Fossil fuel combustion inadvertently creates reactive nitrogen as well. But most of the reactive nitrogen that goes into this total that's keeping up with human population has been created by an industrial process, the Haber-Bosch process, that makes industrially makes fertilizer that's then applied to fields for crop growth. The range of natural nitrogen fixation by both naturally occurring species in natural ecosystems and by lightning is around here. And so what you can see is that the total anthropogenic contribution to reactive nitrogen is now about double that of what's natural. Again, this has had the great benefit of feeding the growing human population, but excess reactive nitrogen can cause problems as well. And so this happens through formation of smog and haze, and tropospheric ozone around where we live and where there's a lot of fossil fuel emissions and emissions of ammonium. Excess nitrogen in soils can cause loss of biodiversity, that is by a few species outcompeting many other species, a few fast-growing species outcompeting many other species in natural ecosystems. Nitric acid inputs is a component of acid rain that hasn't necessarily been modulated by a lot of the emissions controls on Midwest factories, for example, and can still cause acidification of sensitive lakes and waterways as well as soils. And nitrate runoff contributes to eutrophication and aquatic dead zones. I think a lot of people are familiar with the dead zone in the Gulf of Mexico, for example. And then nitrous oxide is both a potent greenhouse gas, and it contributes to the destruction of stratospheric ozone, the protective ozone layer that I'm sure everybody's aware of as well. So what's interesting too is that nitrogen has a lot of different biogeochemical forms, reactive nitrogen. So you can see some gaseous forms here, dissolved in water in the soil and in lake water, and then going back to gaseous forms here in N2O. So this is really interesting to a geeky biogeochemist like me to understand how all these transformations take place. But for management purposes, what that means is that a single molecule of nitrogen can go through this, what we call the nitrogen cascade, and have multiple different effects at different parts of the landscape and in the atmosphere. So in the 2003, the International Nitrogen Initiative was formed to try to better manage nitrogen. And their goal is to optimize nitrogen use in food and energy production while minimizing the consequent harm to humans and the environment. And Jill Barron at Colorado State and the USGS is the director of the International Nitrogen Initiative's North American region. And through this, they're aiming to do several different demonstration projects across the globe in regions with different nitrogen constraints. And so they're working in developing areas that have too much nitrogen, such as South Asia, East Asia, and Latin America. Developing areas such as East Africa, where there's insufficient reactive nitrogen to actually support agricultural production that the population needs. Regions with transition economies, such as Eastern Europe, and then regions like us, Western Europe and North America, developed areas with too much nitrogen. And so they've got pilot projects or demonstration projects going on in all these different regions. And as they're casting about for a North American project, it came to this region they became aware of this region. And what's interesting about the Nooksack-Lower Fraser region is that it has all these different issues, both the positive sides of nitrogen with agricultural production and the negative sides of nitrogen in a relatively small region. It also has these interesting transboundary issues between Canada and the US as well. So part of the goal of this project is then trying to look at how do we maintain livelihoods, how do we maintain community, and at the same time do better for the environment. And so this Nooksack-Lower Fraser Transboundary region is now sort of officially one of the International Nitrogen Management System demonstration projects. The goals here are to develop what we call a nitrogen budget. Even if you can't balance your checkbook, you know what a budget is. You look at what's coming into your bank account, you look what's going out, you look at how much that bank account changes. We're doing the exact same thing with nitrogen in the environment. So if we've got atmospheric nitrogen here, this is an example at a global scale of how a budget can help you deal with some of these management questions and understand what we can do to improve the situation. So we've got fossil fuel and biofuel combustion that creates certain amounts of nitrogen, and we can look at the amounts of nitrogen inputs through those pathways, the Haber-Bosch and the biological nitrogen fixation pathways going into crops, nitrogen going from crops into animals and into people, and from animals into people, and then the different loss pathways into the environment through those pathways. And by looking at each of these pathways, we can identify hotspots where nitrogen management can help us decrease reactive nitrogen in these different wedges here. So the geographic scope of this project is the Nooksack transboundary region here. So we've got here's the Nooksack drainage, the Abbotsford Sumas Aquifer outline here. And one of the things that they were looking at for this nitrogen management system demonstration projects is some transboundary issues. And we have those here. So we've got nutrients flowing from some of the fish trap and the Bertrand Creek into the Nooksack drainage. We've got water in the Abbotsford Sumas Aquifer flowing generally this direction as well. But what we're getting from Canada in water, we're sending back to them through the airshed, which the general flow is going this way. So there's a variety of different policy issues associated with differences in policy in Canada and the US. There's differences in land use within the basin. The downstream effects are local. Everybody here is part of this, is and can be part of this project and part of the solutions. And it provides a tractable geographic region to get people together to work on the issues. And there's lots of past and current efforts, and there's a lot of data availability out there. And so one of the things that the project's been working on is trying to pull all the relevant data together so that we can put together a budget for this region. So the overall approach then is a locally collaborative approach. And when I say local, I don't mean just local here, but in the whole project area across both sides of the border that has international relevance. So optimally, what we'd like to do is be able to take some of the solutions and strategies that we develop here and be able to make them available to the broader international community for nitrogen management. It's multi-perspective. We're reaching out to lots of different stakeholders. Our goal fundamentally is to go back to a data-driven, locally validated, comprehensive nitrogen budget. That is, what we want to do is put together a nitrogen budget that everybody from all different sides can agree on. And this goes back to my question to Brad earlier, how do we avoid politicization of science or polarization of the science? Because we feel that having this fundamental scientific basis to go on, a set of basic facts that everybody can agree on, gives us then a springboard to looking to collaborative solutions. We want to account for trade-offs and synergies, other working groups, which I'll touch on in a couple minutes, and then other reactive elements. Nitrogen isn't happening alone in the environment. It's interacting with phosphorus. It's interacting with fecal coliform. Some of the sources are the same. Some of them are different. And so we want to be aware of those different trade-offs. So we're going to be working on this nitrogen inventory, the nitrogen budget. This is sort of the science part of things. But we want to do that science in the context of the local communities. What do people want to know from this budget? And what are the concerns with putting this budget together? So we're starting to do some outreach to different groups to get their input on the science so that hopefully when we get the science done, everybody's happy with the whole process by which we've developed it. And then we're also doing a policy analysis, looking at some of the policy issues that lead to constraints and opportunities for rectifying the problems. So the nexus of all these things is what we're hoping is going to be our solution space so that we can then evaluate potential solutions. What are the pros and cons of different solutions, and where can we find win-win solutions where if there are trade-offs in solutions, can we work to minimize those trade-offs in a way that's going to help everybody come on board. Then develop recommendations for what some of those solutions can be that have been vetted by a broad perspective of the community. And right now we're in the process of looking for funding for all this. The International Nitrogen Initiative gives us our framework, but doesn't necessarily give us any money to do this great work. So we're working on funding, and ultimately, in the long term, what would be good is to sort of have this project help with ongoing implementation, analysis, and communication of the results. That is, can we fit this into an adaptive management framework that's working towards watershed goals. So far, we've had a couple of workshops, one about a year ago, and then most recently, just last week, we brought together and started some of our outreach efforts. And this workshop, we're working on putting together a charter and an outline of a work plan and develop plans for future outreach. So many of you will be hearing from us as we try to do that. The nitrogen budgeting work is being headed up by Janet Compton and her postdoc Jaja Lin at EPA out of Corvallis. They're trying to pull all the numbers together. There's air transport modeling that's being done by Donna Schweedy, also at EPA in North Carolina. That's feeding into the budget and also looking at air quality. And we're doing monthly phone meetings, and this is an open process. So if you're interested in what we're doing, you can contact me. And if you want to participate in those monthly phone meetings, you're more than welcome to. And then we're pursuing funding. Janice submitted an EPA grant, and we're looking at funding to do the policy analysis through the National Socio-Environmental Synthesis Center as well. So I'm running low on time, so I'm not going to get into all the budgeting details, but here's a course budget, and this is right now very, the numbers are just starting to come together. So we're looking at inputs, atmospheric inputs. We're looking at transformations within these different nitrogen pools, as it were. And we're looking at outputs, both to aquatic systems and export of animal feed or animal products and food products, crops as well. And so trying to put all these numbers together, we have just a few of them which are here. I'm not going to go into those numbers now. This is just what that looks like, some of those inputs, some internal cycling of through manure, outputs through crop nitrogen. Basically what we're finding is that we're trying to be thorough in looking at all of our inputs, but right now the agricultural inputs are dominating, but we still aren't at the answer here, because this tells us how much is coming into the system. It doesn't tell us about the balance. So we've got some crop export here, but we don't know how much of the rest of that nitrogen for agricultural purposes is being taken up by crops or being stored in the soil, things like that, because it's not just the net inputs we're interested in, but what's the balance of those inputs relative to demand. So the budget's not completed yet. There's several more inputs, internal transformations, and exports to put in there, and we're working to validate these numbers with local communities. So we're reaching out to the ag community, to stream water measurements, to a variety of different sources to help validate these numbers to make sure that we're on track. And then finally, we want to merge them with a Canadian nitrogen balance. So I'm going to talk about this in detail in the next 30 seconds. No. This is Shabtai Bittman at Agriculture and Agri-Foods Canada has put together this nitrogen budget for the Lower Fraser. This is where we're aiming, and what we want to do is make our nitrogen budget commensurate with theirs so we can start to merge information sources from both sides of the border. This is just quickly some of what our future work is. I just want to focus on this last one to wrap up, which is how to best complement other efforts, because there's a lot of efforts going on through a variety of different agencies and working groups and things like that are looking at similar and related questions. So we want to interact with those to avoid repeating work, build on each other's networks, and avoid stakeholder burnout as we reach out to people to get their understanding. And so this is just a partial list of some of the groups that are out there. If you're involved in any of these groups and are working on similar types of questions, we'd love to hear from you so we can figure out how we can best complement each other's work. Thanks.
We have 2 minutes for questions if anybody has them.